Hello everyone, and welcome back to another video. So, Cheap As Chips round 2 of 2023, probably the last round of this year, is now over. And yeah, I want to go over my final session, because there was another session. If you caught the live stream, you will have seen that I didn't sub GPU Pi the first time because my Benchmade wouldn't work. So that is what I now did, and I do want to go over the last couple mods I did on the card because I'd added more mods. And there was also a bit of a complication with the card that I also want to go over, and the fix that I did, because this card is actually it's kind of dead. Like, by any means, this card should be dead. If you look at this corner of the die right here, that's a piece of the die that's gone. That is physically no longer attached to the die. That is just a hole, essentially. The card should not work in this state, and it doesn't. But I made it work again with a trick that I don't think I ever did a video about. I really should, because it's a very useful trick. It's just kind of annoying to make a video about it, because it's just, you need to take the BIOS file from the card, open it in a hex editor, find a specific few hexadecimal values, and then change them to something else. Because what this removed piece of the die causes is that the D channel, these two memory chips, the fourth memory channel on the card, is dead. Like, dead. Like, the memory controller is right there in that corner, and a piece of it got removed, so there is no fixing that. So the first three memory channels, like A, B, and C, those are still working, but the D channel, that one's dead. So yeah, and what this mod does is you can go into the BIOS and you can actually tell the card to not use one of the memory channels, depending on what hexadecimal values you put into the BIOS. So I told the card to no longer use the D channel, and that made the card work again, because now it's only using the three remaining channels, which work just fine. Problem being, well, I now have one less memory channel, so instead of 1 GB of VRAM, this now has 768 megabytes, and instead of 256 bits of memory bus width, it now has 192 bits. Which is a problem, because now the card just performs worse. Now, here comes in handy that the only thing that I still really had to sub was GPU Pi, and GPU Pi traditionally is not memory heavy. So this should be fine, you know? I should be able to run GPU Pi on just one functioning channel, and I still have three. So this should be working just fine. Turns out Fermi, like this architecture, for some reason, is actually memory sensitive in GPU Pi. I have not seen it happen on any other architecture. Usually people actually underclock their memory in GPU Pi to get a little bit more core clock. This gets you a better time in GPU Pi if you leave the memory clock high. I don't know why, I've seen it before on a GTX 570, and this does it too. So me losing that memory channel did actually also end up harming the score, and also the core it's just no longer as good post losing this piece of the die. And if you wonder how I lost that piece of the die, I kind of have no idea. The card was set up from the last live stream. I did a few more attempts to do a couple sessions, but they didn't really go anywhere because the card just dropped PCIe lanes, or I just couldn't get the clocks to work that worked on the live stream, and I was just like, I'll do it later. And then the last weekend of Cheap Ass came close, and I was like, you know, I should probably repaste the card. If this is gonna be my last attempt, I should repaste the card. So I took the phase change off, and with it came that piece of the die. It just stuck to the phase. Just kind of like came off. And I looked at it and was just like, damn, guess it's dead now. So That's the story of how this thing lost a piece of its die. I have no idea, it just came off. So, yeah, that's unfortunate. But, you know, got the card fixed up, and it still ran. It's just, you know, in a competitive overclocking kind of way, not really optimal anymore. So I ended up not rerunning my Firestrike or Cloudgate. Those scores have not changed since the live stream because I can not match that anymore. Like, in addition to losing memory capacity and bandwidth, the memory lost like 400, now even more, 500 megahertz of clock. Like, instead of doing 2600, this now does 2100, which is pretty pathetically slow. Core, similar thing. It lost about 50-ish megahertz, and that was at a lower temperature than before, because since the live stream, temperatures have come down. Like, my ambient temperature was pretty much exactly like 10 degrees lower than during the live stream, so the phase was also about 10 degrees lower. And I got worse clocks and worse voltage scaling, which is, I blame that for it. I don't blame the temperature, because really, like, so many people did LN2 and they scaled to the exact same voltages as I did on my phase previously, so, like, I don't think temperature is gonna be a problem here. But yeah, in some pre-testing that I did in like the in-between sessions before the card lost a piece of its die, I did some pre-testing, and basically the card would scale to around 1.4 volts. And in GPU Pi, I could be expecting something around 1400 megahertz core clock. Now, what I actually ended up running is a bit lower. So I did my first session, which was really bad. I ended up rolling over at like stock voltage. Like literally 1.2 volts was giving me like lower overclocking results than just leaving it at stock voltage, which is like 1.15. So that was bad, really bad. And the core clocks reflected that. It was doing like 1100 core clock, which is 200 megahertz less than what it did in Firestrike. And we're talking about GPU Pi here, so that was really bad. And at that point, I just wanted to get a score to sub, because I had completely given up on this card ever doing anything impressive anymore. Now, ASIC was also there. He was LN2 benching his two remaining cards. He also had a bit of bad luck, like one of his cards just kind of died, and the other one just kind of also degraded like mine. Like, there wasn't anything wrong with his card, it just wouldn't run the clocks anymore. So we were both like in Discord streaming to each other and just going like off on the card, just like, why is it not doing that? Anyway, I eventually ended my session early, because I only had this one card and I only had GPU Pi to run. And then I was tearing it down, and I noticed I had like the worst mount possible. Like literally, there was a thick layer of thermal paste on both the die and the phase. It made contact in like one corner of the die, and I'm honestly surprised it didn't destroy another corner of the thing. Like, contact was super bad. And I figured out why. Because the mounting hole spacing of the 560 Ti, you can see it's rectangular, it's not square. And my GPU bracket doesn't actually have the rectangular spacing for the 560 Ti. It has the rectangular spacing for the GA102, like the Ampere cores, like the RTX 3080. Not this old thing. So my GPU bracket for my phase change doesn't actually fit this. So I was using the CPU bracket that I had drilled extra holes into that would fit this. But those holes were printed with pretty low tolerance, and the screws that I used actually ended up bending. And because they were bent, it like didn't make proper contact anymore, because I couldn't get it like down properly. It didn't notice until I ran the card. So that's why the mount was so bad. So I decided to go to the proper GPU bracket, and to solve the it doesn't have the spacing issue, I just used 2 screws instead of 4, and just did like a diagonal mount, which is sketchy, but led to better mounting contact than the thing I used before. So I did another session with this mounting system now, and that had much better contact and the card ran better, but still not quite to the expectations I had. So the voltage that it rolled over was now around 1.35 volts, and the core clock reflected that. You know, could bike on the street, sorry for that. You know, before it was 1400 megahertz core clock and 1400 millivolts voltage. Well, now it's 1350 millivolts voltage, and guess what? It did 1350 megahertz core clock. I think I actually got a run at 1362, but that needed like several reruns to happen. And that's pretty much where the card ended up. So yeah, by now that is a higher core clock than what it managed to do in Firestrike and Cloudgate, but it's not quite as high as what I saw in my pre-testing while I was still figuring out how to make Benchmade work. So it's still a bit disappointing, but it landed me in 12th place for GPU Pi, and at the end of the comp I'm in 10th place, so a top 10 finish, even though by the thinnest of margins. So, like, ultimately, the results I got were fine. Honestly, I didn't really spend a lot of time on this cheap-ass comp. My uni semesters, has started while the comp was active, and I have a very unoptimal lecture time plan. Like, I have a lot of lectures really late in the evening, meaning that I have little free time in the morning and even less free time in the evening. And neither portions of free time I have per day are like enough to really do anything. So really I only have Friday to do stuff, which is a lot less days per week to do stuff than previously. So video production and pretty much everything else that isn't university is just kind of grinding along very slowly. So I didn't exactly spend a lot of time on this. I could have probably gotten better results. I could have maybe also been a bit more careful and not chipped the die on this thing. And I think for future cheap-ass comps, I'm going to make it a policy to always have at least 2 cards, so stuff like this can't happen. So I got this year, for both the cheap-ass comps, I only bought 1 card. I only bought one HD 6850, which screwed me over because that 6850 turned out to be absolute dog shit in the core department. And I only bought this GTX 560 because, well, you know, again, I thought I only needed 1 card and I can just get a second if I break it, not really thinking about the part where, like, if I do this in the last week of cheap ass, there's not really enough time. So yeah, so this card got damaged, and I did not have a backup. So going forward, I'm going to always get at least 2 cards, so I do have a backup. And yeah. Before we continue on, let's welcome back our returning sponsor, PCBWay. PCBWay is a great supplier for getting PCB prototypes made and quickly shipped to your door. The ordering process is simple. Just select and fill in your PCB's parameters, click calculate and then save to cart, then fill in your recipient information and finish off by choosing your payment method and shipping option. PCBWay also offers PCB assembly services as well as more advanced options like flexible and more complex PCB manufacturing should your project have a more ambitious scope. If you have manufacturing needs that don't involve circuit boards, you will also find options here, as PCBWay also offers CNC and 3D printing services as well as the option to build an SMB stencil for your project. I was almost about to end the video and didn't even talk about this. Yeah, this is like the one kind of part that I'm slightly mad about, because I did all of this work modding the card again, and then didn't get to run it once before it broke. So previously, we've had all of this bulk capacitance on the vCore VRM and then all these little wires for volt modding, and also this little wire which might help with cold bugs, but really we shouldn't. Like, I don't think that did anything, but, you know, if it did, that's a mod. So yeah, and that was, you know, okay. but really just putting a bunch of CAN types on the bulk output is it's a cap mod. It's a cap mod that works, but really it's not very effective. So at the end of the first session, the one I live streamed, it was pretty clear that the card would probably like multi-layer ceramic capacitors behind the core, which is what you can see right here, because the card was just, there was a very harsh voltage rollover point, and yeah, so the idea is, if you have better capacitors, you have better filtering, and when you have better filtering, you can lower your voltage and still get the same voltage minimums. So you keep the stability, but you run a lower average voltage, which reduces hotspots and power draw, and all of that ends up, basically the card gets the benefits of running at a lower voltage while keeping the advantages of running on a higher one. That's why capacitors are good. And yeah, so I stacked these multi-layer ceramics. Like pretty much any of the bigger multi-layer ceramics behind the core got a body stacked on top of it. That is what you can see through the insulation right here. And then I thought, still have this bag of lots of CAN types. And I was just, a couple more can't hurt, right? Like I did actually hit on my GTX 260. I did hit the point where I had too many capacitors on it and the thing started shutting down on me. But I didn't hit it here. So, we have these little SMD polymer caps all around the core. These are actually all V-core. And what I did is, I used my very nice and strong new soldering iron to just piggyback capacitors on top of these, because the iron is just that strong. I can just melt the taps that the SMD caps use. And so every one of those got its CAN type body for even more V-core filtering. And then I also added these two to the memory VRM. These are actually 1000 microfarad capacitors, not 820s like the rest. And I did this because, again, the memory before the card was damaged was really, really good on this. And it did scale with voltage. However, Fermi, just like Tesla on NVIDIA, is a generation where the memory chips are usually not the limiting factor. The limiting factor is usually actually your memory controller. Because on some cards, you will have memory chips that are rated for a higher speed than you will actually be able to overclock to. So the problem is not the memory chips. The problem is the memory controller not being able to keep up with the memory chips. So the idea was that because this is just a single phase memory VRM, like that's the entire memory VRM, that is going to massively help, filtering and, give a higher effective voltage to the memory controller without me having to overvolt it to like 1.8 volts and risk it dying. And, well, I didn't really get to test that because, again, I modded this and then the very next thing the card did was lose part of that die and the memory proceeded to now be shit. And then the last two things is, these are just some 16-volt input filtering capacitors. I don't specifically have input filtering capacitors. I just have like a, what is it? Like here, some of these. This is just like stuff I harvested of dead cards and like projects that I ended up scrapping. And I just saw like a couple 16-volt caps and I was just like, yeah, like putting more input filtering on my GTX 1060 helped it a lot. And this isn't exactly a lot of input filtering. So I just put these on, and who knows, maybe they would help. Like, I can't tell because of the damage the card has degraded and clocked, so I can't tell if these did anything, but, they can't hurt, is essentially what I'm trying to say. So, yeah, that's the additional mods to this. And I guess with that, we are done with Cheap As for this year. I don't think they're gonna make another comp because it's like middle of November now. So I guess we'll see each other for Cheap As Round 1 2024 in a couple months. And until then, well, I still have a couple backlog things to do Also, my 3D printed RC planes are advancing. That's probably the very next video, because quite a lot of stuff has happened. I have built and flown one by now. Not the F-111, it was a different plane, but I did build one and fly it. And the F-111 is coming along nicely as well, so there will be a video about that, because, pretty significant milestones have been achieved. But that is outside the scope of this video, and we are nearing 20 minutes, so I would like to use this opportunity to say thank you for watching, and until next time, goodbye.